Hey guys, welcome to AlgoYogi, and today we will be solving minimum distance between BST nodes. So let's go to the problem. Minimum distance between BST nodes. Given the root of a binary search tree, return the minimum difference between the values of any two different nodes in the tree. So the title of the problem and the description of the problem is kind of a little bit misleading. They don't align very well. So it's asking for distance, and then in the description it's asking for the difference, and I think we will return the difference because that's what the problem is asking. And since it's a BST, we'll be using a property called in-order traversal of a binary search tree. And when we do an in-order traversal on a binary search tree, it returns us the value in a sorted array order. All the values we get are sorted in an order. So let's see how we're going to solve this. Let's change the view here. So as you can see, in this binary search tree, the answer is 1. Answer is 1, and the reason answer is 1 is they might have selected 1 or 2 or 2. So 1 and 2, their difference is also 1. 2 and 3, 2 or 3, this pair is also 1. So the minimum difference that you get in any of these nodes, it's not less than 1. So that's why they have returned 1. Now, in order to solve it, what we can do is we can check for every node. We can compare the values basically with every other node, but that will take basically for 4 I'll be comparing its difference with every other node, and then I'll be doing that for every node. So that will take basically big of n square time complexity, and that's the brute force approach, right? Like apply any of the traversal method here and then just compare that node's value with every other node value. You can just even store that in an array and then compare basically using that array values. However, like if and we talked about, we're going to use the property in order traversal property here. Like the order that we will be getting will be basically a sorted array, and then once we get that sorted array, we can basically do just one iteration and compare that value with the previous value. Because let's say if we are doing the in order traversal here, in order traversal, what values we'll be getting? So in order traversal is basically left, root, and right. Just I don't want to mislead here, so that's why I wrote right. So left, root, and right. Now we'll keep going left in this one, in this subtree, and then this subtree. So we get 1, then we get 2, and then for this subtree we get 3. We come back to the root, and then we get 6. So see, we have done in order traversal here, and the order we are getting is sorted. Now tell me, if I start a pointer on the first value and go up to n-1 or n-2 index, and then I compare each value with the next value, or you can do it in any order as well. Like you can compare basically, you can start your pointer here and then you can keep comparing with the previous value, because the minimum difference we will be finding with the b, it will be present between two close values, right? Because they're sorted. You don't want to compare 1 to 4, right? You're not going to compare 2 to 6. You're not going to compare 1 to 6. You're going to compare either these two, the pair that are next to each other. They will give you the minimum difference, right? That's what the math says. Okay, so let's go and implement this. Really simple problem. Okay, let's write the solution. We're going to have array to store the sorted array order when we will be basically using the in-order traversal to store that sorted order of the nodes. And then we're going to have for the answer min difference, that could be for now infinity. Let's define our order function, helper function, that will say if root is none, then we'll basically return. Otherwise, we're going to call a recursive function on left side, then we process the root. That's how we do it in the in-order traversal. We will basically append that value to our array root.val. Same thing for the right side. Let's call our in-order on the root, that will fill up our array, and then we're gonna run a loop from array from the first index to length of the array, and then we're going to compare our value with the previous index value, and minimum diff could be minimum of minimum difference, or array I minus 1. I hope that's clear. Okay, now what? Just return. Okay, let's try to run it. I hope there is no typo here. That passes, so let's submit it. Cool, 100%. Anyway, okay, so now what? Time complexity, big of n. And in the brute force approach, what we would have done is we should have just, if we didn't know this property that if we traverse a BST in order traversal method, then it gives us the sorted order of the nodes. If we didn't know that, we would be comparing using 2 for loops, every value to the every value, then it would be big of n. So brute force could be big of n, and then because we know that property, then we can just simply iterating it once and checking it with the previous index value. So, and space complexity will also be big of n. This time let's not call it h because of the recursive function, because we are storing it in the array, and that would basically be big of n. Awesome. Let's go back to AlgoYogi and mark this problem solved. Okay, see you in the next problem. Bye bye.